Okay, guys, so we're gonna solve radical equations today. So for the starter question, again, I'm starting off with something really simple. So I'm just gonna ask you to work these questions out, find the answers. But while you're doing that, also ask yourself, um, why is it that you're proceeding in such a way? Okay, don't just find the answer, kind of like understand what is your first step? Why is that your first step? Okay, so kind of like ask yourself a lot of questions as you're doing this, as opposed to just following a procedure. Okay, so I'm gonna ask you to pause the video, do that, and then I'll give you a detailed explanation of how we actually apply algebra. Okay, so for the first question, again, any question in algebra, what you have to do is you have to use BEDMAS in reverse direction, okay? And you might be wondering, well, why is it in reverse direction? And the answer to that question is because, as you can see in this equation over here, you already know what the final answer is, right? You know that your final answer is 29, but what you're interested in is what was the x value that you started off with, right? So you have to backtrack your steps, which is why you are essentially using that mass but in reverse direction. Okay, so how does that work? Okay, so addition and subtraction, right? They have the same priority. So you always have to get rid of addition and subtraction, whichever one comes first. Okay, um, then you have to take care of multiplication and division. And again, it's whichever one comes first. And then after that, you have to get rid of your exponent. And then finally, your brackets. Okay. So remember, radicals are the same thing as exponents. So we're going to have to deal with our radicals at the very last step, okay? So let's do these easy questions first. So again, um, algebra tells me to get rid of addition and subtraction first. So I have a plus 5. I'm going to get rid of that by doing the opposite. So minus 5, minus 5, okay? Um, so this cancels out, and then you have minus 2x is equals to 24. And then this is a multiplication, right? So minus 2 times x, so you have to do the opposite. Divide by negative 2, divide by negative 2. So x is just equals to minus 12, okay? Same thing over here, slightly more complicated, but again, remember, there is an exponent, yes. It is a quadratic equation, but there's only one x, so you can kind of isolate for that x and then get rid of your exponent at the very last step, right? So what you have to do is you have to get rid of addition and subtraction first, right? Based on what I've just told you over here, okay? So get rid of the minus 1, do the opposite, do plus 1, do plus 1. So this cancels out, and then you get 3x squared is equals to 9, right? And then you have to get rid of the 3, right? Because next thing is multiplication or division. So before you tackle the exponent, make sure you get rid of your multiplication or division. Okay, so divide by 3, divide by 3. The 3's kind of cancel out, and then you get x squared is equals to 3. And then finally, you have to get rid of your exponent. How do you do that? Well, you have to take the inverse, right? So the opposite of um, square root is square root. And remember, when you take the square root, you have to put a plus and a minus, okay? So x is just equals to plus and minus square root of 3. So now we're going to extend this logic to radicals, okay? So how do you solve radical equations? Exactly in the same fashion, okay? So we will have to rely on BEDMAS, but in reverse direction. Okay, so is there an addition and a multiplication that I can get rid of? Yes, there's this 5 over here, right? So this is plus 5. I can do minus 5, minus 5. So this disappears. So that leaves me with um, square root of 2x minus 1, right? And 12 minus 5 is 7. Now, there is no multiplication. Be careful, guys. So whatever you have inside your square root, you can think of that as your bracket. Okay, so because the square root kind of like applies to both things inside your radical, so don't get rid of, I know that this is a minus, so you might be tempted to think that, oh, based on bad math, I need to get rid of this minus one, but think of it as that's inside your bracket. That's the very last thing that you're going to get rid of. Okay, so let's not do that. So let me just remove the brackets for you. So how do you get rid of the radical? Um, So before you get rid of the radical, one thing that I would like to point out, it's important, make sure when you have a radical equals to something, that this something is positive. Okay, so the 7 has to be positive. If it's not positive, then there will not be a solution. Okay, and that's basically what will happen in the next question. Because remember, whenever you take a square root of something, your answer is always a positive value. Okay, so 7 is positive, so that means that we can proceed. So let's do that. So the opposite of square root is squared. So I'm going to square this. I'm going to square this. The square root and the squared will cancel each other out, right? So I'm going to be left with 2x minus 1 is equals to 49. Now I can get rid of the subtraction. So plus 1. So that means that 2x is equals to 50. And then finally, multiplication. So the opposite is division. Divide by 2, divide by 2. So x is just equals to 25. Okay. Now let's do this question. So again, right, based on bad math, I am going to get rid of this 2 first. Okay. So I'm going to do minus 2, minus 2. So that leaves me with minus 5x plus 1 is equals to 10, right? Next, I have this minus 1, so minus, which is a minus 1, right? You don't see the 1, but it's essentially minus 1 times square root of 5x plus 1. So how can I get rid of that? Well, you can just divide by minus 1, or divide by minus 1. So this gives you, actually, I'm using a lot of space over here, so I'm just gonna erase this whole thing and then show you something because I need all that space. So what will end up happening is these 2's will cancel. So then I'm going to have minus square root of 5x plus 1 is equals to 10. And then you divide by minus 1, then you divide by minus 1. So this becomes 5x plus 1 is equals to minus 10. Now, once you get a square root equals to a negative number, you can just stop there and say no solution. Okay, so that's what I'm going to ask you to do. But what I'm going to do is I'm actually going to proceed just to show you that if you choose to proceed, and if you're stressing on an exam and you forget about this, right? So what you have to do is take the square root, take the square root. So this becomes 5x plus 1, and then you get 100. Right? Square root of negative 10, minus 10 squared is actually 100. And then you'll have to remove 1. So minus 1, and then you have 5x is equals to 99. And then you divide this by 5, divide this by 5. So x will equals to 20 times 5 is 100. So I think this is 19.8. Okay. So you will get an answer at the end, but when you validate your answer, it's not going to give you 12. Okay, so let's check. So 2 minus 5 times 19.8. I know that 5 times 19.8 is 99, right, based on this. So it's just 99 plus 1, which is 100. So 2 minus a square root of 100 is equals to 2 minus 10, which is equals to minus 8. So it will not work. It will not give you 12 um, because of this step. Okay, this step um, is where you have to convince yourself that there is no solution. Now, if you find a solution, it's fine, but always make sure to check your answer, which is something that I should have done over here. So this one should work. Okay, so let's see. 25 times 2 is 50. 50 minus 1 is 49. Square root of 49 is 7. And 7 plus 5 does give me 12. Okay, so this one will work. That one will not. And it's because you actually made a mistake over here. Now, there's actually a, a reason behind this. I'm not going to go into the detail because, we have to kind of like condense the material. So the only key takeaway here is to understand that this is not equals to 12. So there is no solution. Okay, no solution. But you could have stopped over here if you wanted to. Okay. So now what I'm going to ask you to do is why don't you try solving this question on your own? So pause the video. I'm going to proceed, but you can pause the video and then check your answer. Okay, so how would you do this? Get rid of, again, bed mass in reverse direction, right? So we need to get rid of this. So let me just write this out for you again, bed mass. So you have to get rid of addition and subtraction. So this is a subtraction. So plus 8 plus 8. This disappears. And then you have 3y over 5. Square root of that is equals to 6. So this, right, I have a square root equals to a positive number. So this is a good sign. This means that I will have a solution, so I can proceed. Okay, so I will square my left-hand side, square the right-hand side. So that gives me 3y over 5 is equals to 36. And then I'm going to get rid of the 5, so times 5. And then uh, times 5. So the 5s will cancel, and then you get 3y is equals to 180, I think. 5 threes is 15, 6 5 is 30. And then you divide this by 3, divide this by 3. So y will just equals to 60. Okay, and then you can check. So 60 times 3 is 180. 180 divided by 5 is hopefully 36. And then square root of 36 is 6. And then minus 8 plus 6 is minus 2. So this will work only because in this step, your square root was equals to a positive number. Okay, I hope that kind of makes sense. Now, it can get a little bit more challenging. So here they're talking about the extraneous root. Okay, so make sure you know what the word extraneous means. Kind of like um, with the quadratic formula on the test, they asked you to find out what the discriminant was, right? And some of you did not know that. So make sure you are familiar with these definitions. Okay, so extraneous roots may appear when we have to solve a quadratic equation. Okay, so in this case, I'm going to have to do the same thing. So the trick over here is to have the radical all by itself. Okay, so what you have to do is you have to move this n um, and then divide by minus 1. That's one way of doing it. Or I think a better way would be to just move the radical to the other side. So let's just move this over to the other side. So this becomes n still stays here, right? So this is just n. And then when you move the radical over, you get this minus sign will turn into a positive, right? So it's just going to be 5 minus n, square root of 5 minus n, minus 7. And then you can move the minus 7 over, okay? So you can move it over, change the sign, or you could add 7 however you want to do it, it doesn't matter. So this gives you n plus 7 is equals to 5 minus n, square root of 5 minus n. Okay, so when you have two, see, this question is slightly challenging because here your variable, it's you can your variable n appears in two different places. Okay, so when your variable appears in two different places, then you have to isolate the radical because then you can take the square of that. And when you do that, you're going to end up with a quadratic equation. Okay, so let's do that. So let's square this. Let's square this, right? And if you compare this question actually to the previous one, you will see that in all the previous questions, your variable only appeared once. Okay, so that's why it was slightly easier to solve that one as opposed to this one. Here, you will have to solve a quadratic equation. So how do you simplify this? You just square the first term, so that becomes n squared. Then you multiply the two together. Okay, so that's 7n, and then you have to multiply that by 2. Okay, you have to do that all the time because it's squared over here. Okay, so 7n times 2 is 14n, and then you square the 7, that gives you 49. And then when you square this, the square root disappears, right? So it's just 5 minus n. So to solve a quadratic, you have to make this equals to 0. So this just becomes n squared. And then you have to move this n over to the other side. So the minus n will become plus n. So this will become plus 15n. And then you have to move this 5 over. So this will just become plus 44. Okay, is equals to 0. Now, you could use your favorite quadratic formula over here, but remember, factoring can actually save you a lot of time. Okay, so let's see if factoring actually works, and I think it will. So we have two numbers, so the coefficient of n is not visible, so it has to be 1. Two numbers that multiply to 44, and they have to add up to the middle term, which is 15, right? So 11 times 4 is 44, and 11 plus 4 is 15, right? So because your coefficient is 1, the shortcut tells you to put the variable, which is n, and then put the first number, so that's plus 11, close the brackets, and then n um, plus the second combination, so that's plus 4 is equals to 0. Um, and then, right, so now you have essentially a times b is equals to 0. So either a is equals to 0 or b is equals to 0. So that means either n plus 11 is equals to 0, which means n is equals to minus 11, or n plus 4 is equals to 0, which means n is equals to minus 4. Now, because you've solved a quadratic equation, you have to check your answers. One of them will be wrong, okay? When you have two solutions, when it comes to radicals, one of them has to be wrong. And the reason behind that, guys, is similar to this question over here that I gave you, okay? It's very similar to that. I'm not going to go into the details. What I'm going to ask you to do is always check your answer. So let's check. So if I plug in minus 11 into my equation over here, so 5 minus minus 11 is 5 plus 11. So that gives me 16, right? So again, I'm running out of space, so let's just maybe work this out up here. So if I plug in minus 11, I'm gonna get minus, so this will just become, right, this over here will just become minus, minus 11, and then minus 5 minus minus 11 is 5 plus 11, so that's 16. And then you have to take the square root of that, right? So this becomes minus 11 minus 4, which is equals to minus 15, which is not equals to minus 7. So this is a solution that does not work. So that means the other one will. Now let's try that out. So this is minus 4, okay. So if I plug in minus 4 over here, then I get minus 4, right? I'm just replacing n by minus 4 minus square root of 5 minus minus 4, which is actually 9. So this just becomes minus 4 minus the square root of 9, which is equals to minus 4 minus 3, which is equals to minus 7, which is what I have over here. So this one does work, okay? One of them will not work. So the one that does not work, this one over here, this is what we call an extraneous root, okay? So again, I'm gonna ask you to pause the video, solve this question on your own.